Graph databases are another type of NoSQL databases. Here, data is represented as vertices and edges. So we have a structure that looks like this. You've got some vertices, and on each vertex, there is a complete set of data, and these are connected by various edges. And each edge represents some relationship between the two nodes. So these nodes contain the data, and the edges between those nodes contain the relationship between them. Graph databases are powerful because they enable these graph-like queries. For example, if you need to find the shortest path or you need to quickly access some data, then these are the best that you need to use. The parts of graphs or the elements that it has are nodes, which represent the entities, properties, information about the nodes, and these can be indexed. You can have some form of index values with all of these. And then the relationships are represented using the edges. The edges can either be indexed or not indexed, so you can have your own identification for all of the edges, and these can either be unidirectional or bidirectional. Some of the important properties that it has, that it scales easily to the complexity of data. You can add any number of nodes that you require, and it is since this enables the creation of these relationships, so it is highly focused on interconnectivity. And because of this focus on interconnectivity, it is used in multiple applications which have these social network type structures. Okay, just we have data for Facebook, we've got data for LinkedIn, where you've got connectivity between the various elements, then that is easily stored or processed in if you have a graph-like database structure. Some of the databases that allow creation of graph databases are Neo4j and VertexDB. Next, we have columnar databases. Just as in relational databases, we have row-like structures. Columnar databases allow us to store data in column-like structures. Okay? These are the hybrids of RDBMS and key value stores. So this is somewhere between, or it takes the benefits of both a typical or traditional RDBMS and these key value stores that we have. So values are stored in groups of one or more columns, but in column order as opposed to row order. So you're more concerned with age, and age of all of your employees would be here. And then if you're concerned with name, and you'll get the name of all of your employees, and so on, so forth. As many values you have, you get the same data for each one of these. So if I was to access this one column, if I was to access all of the names in the row order, I'll have to read all 3 rows, but in column order, I'll have to only read the first row, and it would have all of the values over here. So in column order, the sorting or the arrangement is based on columns instead of rows. Then these columns can have locality groups as well. So instead of having data for all of them, you see that we have subsets over here. So Alice's data 3 and 25 are joined together, where we've created one subset, and then 4 and 19, and then 0 and 45. So we've got smaller subsets that we can join together in columnar data. Values are queried by matching keys, and some of the databases that actually use these are HBase, and Vertica. And HBase is also used in Amazon S3 services.